Okay. Let's start. Can you see the screen?
Yes, sir.
Okay. So this is your lab 4. The lab manuals as well as the MLX file has been provided to you in your Google Classroom. Please open your MATLAB. I will ask you to do something. So try to do those things simultaneously so that you can also see and show me what you are doing, what you are getting the results. Achha. So in the first lab, we started with some basic introduction. In the second lab, you saw how to work with digital signal processing, digital image processing. You have some introduction. In the third lab was audio signal processing, and some of the recorded lectures were provided to you by Rakib. Try to see those lectures, okay? For your lab 3, uh, it will be from those recorded lectures, okay? If you don't understand something or if you need some extra class for that one, okay, we can arrange that some extra class later online. First, view those materials that has been provided to you online, okay? Now in lab 4, we are going to look at how to work with different kinds of signals, okay? Signals, there are lots of things that you can do with signals. So you see, any signal contains some information, okay, and we have to have some way to extract knowledge from those signals. Achha, we need to analyze the signal, sometimes modify the signal, things like that. So in this lab, we'll try to see some of those techniques to work with signals, okay, and in different applications. Achha. Mm, Can you see this screen?
Yes, sir.
Okay, so at first, we'll start with peak analysis. And this through this peak analysis, we'll see how to actually perform different operations on a signal. There are lots of things you can do. For instance, if we have a signal like this way, is this a periodic signal or a non-periodic signal? Periodic or non-periodic?
Periodic signal.
Yeah, this looks like a periodic. Why? Because the signal is actually repeating after certain interval. Okay, after certain interval, you have this repetition. Okay, so any times when you are working with signals, usually there is this type of repetition is there. Okay, Achha. So this is very regular. Signal can be very irregular as well. Irregular, like this can also have the shape like this way. Okay, irregular shape. Or for instance, if you look at the ECG signal, okay, it looks something like this. Okay, so this is called QRS. The heartbeat, ECG is the heartbeat measurement. So sometimes it's reaching the top. So this is called QRS complex. So this has a peak, then it goes to another peak, then a small peak like this way. So our heart actually continuously vibrate like this way. Okay. So you can ask this question, like if we put the time frame here, across the time frame here, and if this is your amplitude like this way, you can ask the question like, when I am having these peaks, okay, what is the value? What is the time period? Let's say this is T1, T2, T3. What is the exact time period when I'm having these peaks? Okay. Or what can be the value of these peaks? Okay. So value you can also want to know. What is the time? You can also want to know that one. Okay. What is the distance between this time? What is the interval? What is the interval at which I'm getting these different types of signals, different types of peaks. So if I know the interval, I'll know the the time the time frame of the signal, okay, the time period of the signal through this interval. So you can also ask what is the highest peak in a signal, what is the highest peak, what is the maximum value you actually got. Okay. So through, if you actually try to understand these things, you can actually understand the trend in the signal. Okay. That's what you want to know. Using when you actually try to perform some analysis on the signal, we want to understand the trend. Okay. So signal, like I said, the signal can be different types of signal. We're going to work in particular one type of signal. Okay, it is already provided in MATLAB. If you just load this signal, sports now, okay, there is a function called load. So if you load this way, this two variables will be, uh, you will have two variables in your workspace. Try to load this one in your MATLAB. Okay. Load this signal in your MATLAB. What do you see?
Sir, how to do this? It's not working.
It's not working.
Should I just write the function and then sports now?
Yeah, just load sports now. It should actually provide you with two variables in the workspace. Look at your workspace. In the workspace, there should be two variables created. One is your AV spots, another one is your year. Let me
Yes, sir, they have been created.
Okay, so if you look at your MATLAB, try to open an MLX file. Okay, not in the normal, not MATLAB tab. You can create a live script like this way. Okay, to create a live script, actually, let me clear all these variables here. Okay, so if I write like this way, load spots now. Okay, if I just run it, you see this is the run section. If I just run it, you see two variables are created here. One is your AV spots in the workspace, and one other is your year. Okay, what is the size of this arrays? 264, right? 264 double 1 by 264. That means this is a one-dimensional array, right? It's a one defector.
Yeah.
So if I check the values, AV spots from this section, you can see these values. Okay. So these are the values that you are getting. Okay. Now, what does this value represent? You can ask. So if I try to just plot it, you see those both of them have actually the same direction. That means year-wise value. These are year-wise value. Each year, this is the year information. Let me show you the year as well. Section break. If I type the year, so let me do it like this. Year, right? Okay, so it's like this way. For 1749, this is the year. The average spots, the number of sunspots. Spots is actually sunspots. So the average number of sunspots in the year 1749 was 80.92. Okay, this is like a 1-to-1 relation. In 1750, it was 83. In 1751, this was 47, like this way. Are you following? Everyone?
Yes.
Yes, sir.
Are you getting this value? Anyone have
Yes,
any
sir.
problem?
No, sir.
Anyone any problem loading this data? Okay, so you can see you have all these things here. So what if let's say I want to visualize it? It is very difficult to show it, see it here in this way. If I plot it, I can easily visualize those things. Okay, so let's plot this thing.
Sir,
Yeah,
mine is still taking time to process the program. It's not displaying anything.
don't you have anything in the workspace? Any variable created?
Like, yeah, I wrote everything you've written. Load spots num.mat.
Uh,
I run the simulation, but nothing showed up.
so can you share your screen?
Uh,
There is a share
okay.
screen option. Yeah, we'll share it.
Wait. My MATLAB. When I try to run, like, nothing happens.
You see, it happens. It is happening. You see on the left-hand side, in the
Oh,
workspace, two variables are already created.
oh,
See? Yeah,
yeah.
these
I
are
haven't
already
seen
loaded
that.
in your workspace. Okay. The load file is not showing you anything, but two variables are created. Now, if you
Yes.
create a new section and try to run the FES ports, you can see the values of the FES ports variable. Create
Yeah.
a section break. Section break. You see there is a section break there. Yeah, create a
Six.
section break. Yeah, you are creating a
Yes.
new section. Yeah. Now type FES ports. A capital. Yeah, that's one. FES ports, the first one. You can just click enter, it will work. Okay. Now run section on the FES
Two.
ports, and in the two. Click on the
Yes.
two. Yeah, click on the two and run section. In the top one, you see run section, not run. Now you see the values.
Yes.
Yeah, and those are the
Yeah.
values.
Wow.
I have
All
provided
right.
I have provided you with a Google a .mlx file as well. It will help you see what I am doing directly. Achha.
Okay, sir.
Okay. Now let's get back here. Achha. So now if I want to plot it, let's say I want to plot year, this is on the x-axis, and the average sports on the y-axis. So if I plot it, you can see the figure. This is your signal, right? Signal is nothing but data. You're just plotting it, you have the data. So if you see this data here, do you see any pattern here? Any specific pattern? Can you
No,
see any
sir.
pattern? You see, you are getting some peaks, right? Some peaks, not equal peaks, but
Yes, sir.
different value peaks. But after certain interval, you are getting these peaks, right? As they said.
Yes, sir.
Okay, so when you are here, you can also save this image like this way. If you go to file and save as, this will save your image. Okay, and you can see the format. Save as .fig is a MATLAB figure file. So if you save it, you can only open the image as a in the MATLAB. You can also save in other formats like this PNG format, okay, or SVG format, that is the graphics file, or EPS format. You can also save in the TIFF format, whatever you like, or JPEG. You can save in other formats as well. Usually for visualization, we can save it using JPEG or P. Okay. Achha. So that way you can also save this image. So let's go. You can see here the tools in the insert tab, X level, Y level, title. You can add a title. If you just create it, you can write it like this way: sunspots versus year. This way you can like from this graphical user interface, you can directly modify your image as well. Then we can save it. Is it okay? Any question?
Yes, sir.
Now, see in this image, what do you want to do? We want to find these peaks. I want to find this peak value. I want to look at these peaks. Achha. What are those peaks? Peaks means something that is like in the top position, right? Compared to its neighborhood values. Compared to the neighborhood, the highest points. So there is a function, built-in function given in your MATLAB that is called find peaks. Find peaks. Okay. Find peaks in what? The average spots. Okay. In the average spots, I want to find the peak values. So if I run this section, you can see the variable val, the value variable is created. Now, in this variable, you see what is the size of the variable?
32.
32, right? So that means there are 32 values in your in this variable. So this variable find the peak values. So out of these 264 values that your average spots, it is finding how many? 32 values. That is, it is considering the peaks. Okay. Now you can also ask this question, and in which years, in which locations, this has actually find the peaks. So you can also do this way. You see, you can use a multiple output command. So multiple output commands goes like this: value comma. If I give the location, this will sorry. Okay. Find peaks. So this will also give you the index of it. Index of the in this variable, what are the indices where it is finding the peaks. So if I run it, you can see this is the variable and this is the location. That means in the average sports variables, the second index, that was a peak. Fourth index, that was a peak. 13 index, that was a peak. And these are the values that actually they found. Okay. Now, from this one, it is very difficult to understand. So we need to perform, if I use visualization, it will be much more clear. Okay. That was the purpose of your, in the last year, we have seen how to perform different visualization techniques. So you see, you can plot multiple figures in the same figure, multiple plots in the same figure. So it is like this, a plot. Okay. First, I want to plot this one, our original one. Okay. Then on this same figure, in this same figure, I want to identify these values. Okay. Acha. Before I go there, acha, from this index, can you find the year from this index value? Is it apparent to you what is the year on which you are finding the peaks? মানে কোন বছরগুলোতে তোমার পিকটা আসতেছে? আমরা কিভাবে বের করব? How can we find that? Am I clear?
সেকেন্ড এলিমেন্ট ফোর্থ এলিমেন্ট ভাবে করে
These are the indices, right? So if I look at the year variable,
Corresponding x-axis values.
so the second second value in the year, fourth value, 13th value in the year, that will give you the, you know, oh, so now you can see, so the first peak it found in 1750. The second peak it found in 1752. The third peak was in 1761. You can see here, the third peak is somewhere here. So to visualize it properly, let's put it inside a figure. So plot, then year of this location, comma, my value, all the peak values. And let's identify them as like this way. Okay, so if I run it, now we can see all the peak values. This is the second plot. This is the first plot. On top of this one, you are placing this second plot. In this second plot, what you are doing, whatever the peak value you found from this function, those things are identified here. Okay, see? So this is your peak. This is another peak. This is another peak. These are the peaks your function, the default values of the function actually found. So how many peaks are there? How many peaks did your function found?
30.
No. Is all the peaks are correctly identified? From the figure, what do you think? All the figures are correct? Is this a peak? This one?
কয়েকটা হচ্ছে একটু নিচের দিকে peak।
Is this a correct peak? What do you think? This one?
No, sir.
No, sir.
No. What about this one?
Not correct peak.
Okay. Also, what about this one? These two are very close to each other. Or this one? So you can see there are some peaks that are actually
পিক গুলো
misidentified.
আইডেন্টিফাই করতেছে কিভাবে, লাইক আগের ভ্যালুর থেকে বেশি হলেই পিক হিসেবে কাউন্ট করতেছে?
আচ্ছা বলতেছে জিনিসটা, it actually takes the find peaks function consider the neighborhood pixels, neighborhood peak values. If a certain value, for instance this one, if it is higher than its neighborhood values to a certain degree, then it consider itself a peak. So this value is higher than its surrounding values, right? That's why this is a peak. Also this value is higher than its surrounding values. The window, like how much you should go left and right, that's something comes from the definition. We can also change it, but now for now in this scenario you see this is considered a peak, this is also considered a peak because this is higher than its surrounding values, this is higher than its surrounding values, this is not higher than its surrounding value because this is something higher. So anything in the top, that is identified as a peak. Are you following? So if you consider this curve from this region, if you look at this region, this is only increasing, increasing, increasing. And at this point, it goes to the maximum. Then again, it drops. So it identifies those points where it goes to the maximum level. Okay. So again, from here, it goes to down, down, down. It goes down, then it goes up. Very small, but it goes up. Then it goes down. So compared to this window, this is the highest point. আমার কথা বোঝা যাচ্ছে?
Yes, sir.
So now this default consideration, this is giving you some errors. Okay. So to understand it more clearly, let's look at the function. Let's look at the find fix function. What is it? Low. So you see this find fix function returns a vector with local maxima. A local peak is a data sample that is either larger than its two neighboring samples or is equal to infinity. Okay, that's the default definition that MATLAB uses. This function uses to identify the peaks. Okay, but like we saw that some of the peaks are misidentified, so that's an issue, and we have to find some way to let go of those issues. So before we go there, see, from this one we have found the peaks, and it is located in this one, value and location. Achha. So year of this location, let's define it in a variable peak years. Let's define a variable peak years, year of location. So let's just keep it like this. Now, if I ask you this question, what is the highest peak? What is the highest peak from this one? What is the maximum? What is the highest peak? This one, right?
Yes, sir.
So in which year are you getting the highest peak? Can you guess from the figure?
So 1950.
1950.
Somewhere after 1950, right?
Yes, sir.
Somewhere after 1950, you are getting this maximum or peak value. So we want to identify this one exactly. So you see, this is called local peaks or local maxima. And this one is called global maxima. Global maxima means overall what is the highest peak. And these are the peak, highest peak, but not the maximum one. So the highest peak or global maxima, if I want to find, it should be the maximum value. Maximum value of the AVS spots. So the maximum value of the AVS spots that is 189, right? So this is your 189. That's your maxima. That is a global maxima. Okay. So you can also find the year associated with it. Okay. And to find the year, you have to find the index at which you are getting this getting this optima. You also have to find the index. So you can also call two variables. The second variable will give you the index at which the maximum value is occurring. You see, this is the 209th index. Okay. So what is the 209th index of this year? That is 1957. So that means in 1957, you are getting this highest peak. Is it clear?
Yes, sir.
Okay. So this is the way you can actually find the global maxima. Now let's see what to do with these peaks, this misidentified peaks. Now there are some additional parameters in this find peaks function that we can actually call to make your to make this one much more clear. So let's define it like this: val2 log2 is equals to find peaks in your average spots. There is a function, you can see these are the other arguments. Okay, these are different arguments that is available. We are interested in some of them. minimum peak weight. Now you see one of them is minimum peak distance. What does it mean by minimum peak distance? That means what should be the distance between two peaks. Okay, you see, we want to find repetition in the data. Okay, I believe, or we believe, that the signal is periodic, but this too is making the signal aperiodic. Okay, because two maxima should not be that close. I should consider only one maxima here. Similarly here, I should only consider one maxima. So what you can do here is that you can define that two peaks should not occur within a certain region. Like within 2 years, you should not get two peaks. You should define a range after which a peak can occur. আমার কথা কি বোঝা যাচ্ছে? মানে দুইটা পিকের মাঝখানে at least একটা distance থাকতে হবে. Okay, so that is what you can define using this minimum peak distance. Are you following? Any question?
Yes, sir.
Acha. So you can see what should be the value 2, 3, 4, 5. You can actually ask that. There can be many different values. So what should be the most appropriate value, right? So in scenarios like this, when you have to test many different values, it is easier to put a control bar. From the control bar, you can put a numeric slider here. Okay. So the minimum value, let's make it as 1. Maximum value, let's make it as 10. And the step is make it as 1. And the default value, let's make it as 1. Okay. Yes, sir. Now, if I do it like this way, let's put it here and let's plot it. Plot course now, so that we can see the visualization at the same time. This is your log 2, value 2. Okay, so if I consider the minimum peak distance as 2, you get this figure. Okay, can you see the output? So you see, this is gone, right? This one. So like I say,
Yes, sir.
this is also gone. This is also gone, but this one is not gone, right? This cannot be considered a peak because this is somewhere in the middle between the two peaks that you can see. So you should increase a little bit more, right? Are you following?
Yes, sir.
Yes, sir.
So if let's make it 3. Yes, sir, hoini. Let's make it 4. Now you can see this is gone, right? This is gone. This is also gone. What if I make it 5? 5, this is also gone. I still have this one. This is a misidentified. Let's make it 6. Now see, when I make it 6, now is this perfect? Perfect. Do I have any misidentified peaks? Or have we successfully identified all the peaks? We say.
Yes, sir.
Yes, sir.
So you see like this way. Now, what if I increase a little bit? 7. This one is gone, right? Now 7 is correct. When you do 7,
No,
this one
sir.
is gone. So you have to have like this is to be something has to be done manually. Okay. So 6 is the most appropriate value. Given a signal, it can be different for the signal you are given to. So, but using this one, you can actually get some good estimation. It may not be perfect. It doesn't have to be perfect, but it can actually give you some good output compared to the general scenario. So now you can see this variable value 2. So this value 2 is locating your this value 2 is locating your the peak spots for this scenario. So what is the value 2 size? Now 24. Previously, how much did you identify? 32, right? Now it is lower to 24. That means we have eliminated how many peak values, how many peaks from the original function? How many? 8, right?
8, sir.
8. Acha. So now we can say that this is like our ideal scenario. We can say this is our ideal scenario. And we can also see that if to the log 2, year of log. You can also see the years at which you are getting this one. So first peak is at 1750. The second peak is 1761. The third one in 1769. Fourth one in 1778. So you can also see what is the difference. Difference means after how many years you are getting this peak. We can ask this question, right? So after how many years you are getting this peak values. So there is a function called diff. Okay, difference in the location 2. That will give you the difference between these two variables, two values. These two values, what is the difference? These two values. So if we run this one, you can see 11. The first one is 11. Second one is 8. Third one is 9, 9, 17. That is the years. So after this 1787, after 17 years, you got the next highest peak. Okay. So if you take the average of this one, if I take the average of this one, average of this difference in the location 2, this will give you the average. Sorry, average story এখানে function not function হচ্ছে mean. Function হচ্ছে mean. So what is the mean value? Almost 11, right? 10.86. So almost 11 year. So that means after 11 year, your signal is repeated. Are you following? So after 11 years, these peak values are getting repeated after 11 years. Is it clear?
Yes, sir.
Yes, sir.
Okay, so this 11 year is known as the solar cycle. Okay, এটাকে বলা হয় solar cycle. After 11 years, we get the maximum number of sunspots observed. Because sunspots is a phenomena, is a solar phenomena. আচ্ছা, so after 11 years, this cycle actually gets repeated. The max we have some difference in the maximum value that you are getting, but this cycle is repeated after each 11 years. Okay, so you can say the last one that you found, what was the last one in here? This one, what is the last one? 2000, right? So after 2000, the next one actually happened in 2011, somewhere in 2011. So the last next one should be somewhere in 2022. We have to check what is the last year, what was the last time you get this kind of solar cycle. Okay, this kind of highest peaks. So this way, if you're given a signal, this way you can actually analyze the peak values, and through analyzing those peak values, you can actually determine the cycle of those signal that is actually occurring to you. You can identify the peak values, you can identify the highest peak, you can identify the average distance. Okay, like this way. So this is one type of signal analysis. Okay. you can have different types of signal, and through this one, you can actually find different information regarding your signal. So is it okay? Any question? Any question? No question.
No,
Okay.
sir.
Acha, so just like your minimum peak distance function, remember previously, এটা আপাতত delete করে দিই। Just make it as value 3, location 3, location 3, value 3. Let's put this one. There are some other values always also available, right? You see, there are some other values, other input arguments also available. So you can also test with other values as well. Let me show you another one: minimum peak prominence. So the minimum peak prominence is like, this is your average as well. So you see in your original figure, this was the original figure. So the minimum peak prominence actually is defined like this way. See, from this peak to go to the next peak, how much difference should there be? Like if there are, for instance, this one, there are around 190 sunspots. So for the next peak to come, or you should at least go down certain level. If I say minimum peak prominence is 30, that means it should be reduced to from 190 to 160 before another peak can occur. Are you understanding? If I say the minimum peak prominence is 30, that means whatever the peak that you have right now, from this point, the values should go down at least 30 before another peak can appear. Okay. So here you have 160. So you should first go down the next peak. Before the next peak can come, you should go down by 30 first. Are you following?
Yes, sir.
Yes, sir.
So considering this one, you can see this will not be considered as a peak, right? See, for instance, this one is 157. So if I say minimum peak prominence is 30, so before the next peak can come, you should at least go down by 30. So it should at least reduce to 130 first before the next peak can come. But here you can see this is only 145. Then it will not be there. Are you following? So this is another way. So your signal might require different approach. So this is another way whether you can actually find these peaks. So let's define it. And again, we put a numeric slider here. Okay. So put your numeric slider there in your laptop, in your PC, and see the value. What should be the value so that you can get an appropriate figure like this, the previous one. What should be the minimum peak prominence? Try to find this value. Is it clear? Question clear?
Yes, sir.
Okay, try to do it and let me know.
স্যার আমার জন্য 10 হয়ে যাচ্ছে।
I did not get you. Can you repeat?
Sir, for me the value is 10.
10 এর জন্য পারফেক্ট ফিগার আসতেছে?
Kind of like even if I change it, even if I increase it, I'm having the same values.
Be more, try different values also. Check the numeric slider, try different approach and different values. Check for 15, 20, see, there should be some difference there. See, you are plotting the correct figure or not. Check if you're plotting the correct figures as well or not.
স্যার 10 থেকে একদম 44 পর্যন্ত স্যার মানে সেমটাই দিতেছে আর কি 43 পর্যন্ত।
হতেই পারে। দেন
এরপরে স্যার মানে
পিক্সেল
কয়েকটা
ক্রস
মিস্টেক।
করলে ওটা বাদ দিয়ে দেন।
so what is the most appropriate one you are getting?
তাহলে স্যার
Which-
43
which one give you the best figure?
Sir, 10.
Yeah, show me the output from 10. Let me see. Okay, zoom it. Full screen. Just full screen. Yeah, 10 is good enough. This is for 10, right? You can see all the peaks are there. There is no misidentified peaks, right? What is the size of this one? Value 3. What was this? 23. It
Yes,
means
sir.
we have
23, sir.
24, right?
Yes, sir.
Is it is missing the first one. See,
Sir.
it's missing only the first one. Okay, so that's fine. আর কারো হয়েছে? You can stop sharing.
স্যার 10 থেকে একদম 43 মানে যে কোনো ভ্যালু দিলে হইতেছে সেমটাই দিতেছে আর কি।
Yeah, for this one, you see, for that means 10 to 40, it does not have any effect because your signals are much more, the peak values are located in certain region that is more than 40. That's why. For another signal, it can be different scenario.
তাহলে স্যার মানে বেসটা কি আমরা 10 বলবো, যেটা সবচেয়ে কম
For
ওটাই
this
বলবো?
one, for this signal, it is 10. For another signal, it can be different, right?
Yes, sir.
Okay. Acha, let's see. Yeah. Now, let's look at another signal. Load another signal that is load pix.mat. Acha, let's see. If I load this one, clip pix.mat, this is another given. Oh, so you see, when I load this one, it gives you one variable termed as saturated data. Okay. Section break. Let's see. Data is equals to saturated data. Okay, let's define it as data. So now you see this is your data, saturated data, values like this, values like this. So if I plot it, just plot it, then it will be easier to see. So now you see this figure, this is another type of figure, right? So you see how many peaks are there. This is a peak, looks like a peak, very small peak. This is another peak, this is another peak. Achha. Now, this one, are you getting this one? Some of you might not get this data. Everyone getting this data?
Yes, sir.
For some of you in your MATLAB, this data may not be available, or different data can be there. To change these things depending on the version. Now, see this one in particular, you have studied the clip signal, right? Clipper clumper persona. So this is like a clip portion. Your signal is clipped here. Are you following? Do you understand?
Yes, sir.
Yes, sir.
Yes, sir.
When you have a clip portion like this way, you see, the problem is it does not have a single peak, but there can be multiple peaks to be considered, right? Because this is like a chop down. It can also be very large. So your signal, if your signal is like this, it can be very difficult. So let me show you here. So if your signal, can you see this screen?
Yes, sir.
Now, you can say this is a peak, this is a peak, this is a peak. What about this one? This whole region as a peak? What do you do for this one? Okay. So when you have something like this, you see, usually you want to consider only one peak, at least one, only one. Don't want to consider the other one of them. Otherwise, you have to consider all of them. That will be like not a standard approach. So when you have this kind of clipped signal, you only want to consider only one of them. Okay. So what do? You define a threshold, another parameter that says that if I have a peak here, like what should be the distance that we consider as the same peak. So if the value is like, for instance, if the value here is 50, if you define the threshold as 2, then it will consider all these value 50, 49, 48 as the same peak. আমার কথা বোঝা গেছে? So the
Yes,
threshold
sir.
is like, so this value is like considered as the same value. Okay, this is how we define a threshold. So if you see your MATLAB, let's see. First, you have load data. Let's go to section break. Then we put this one. Okay, find peaks on your data. So there are 19 peaks identified. Okay, now if I try to plot it, oh, actions 19 in the data. Okay. এটা এইভাবে না করে okay. Sorry. Now see. So how many peak values are identified now? See this 1, 2, 3, 4, 5, 6, all of those things. And here you can see this is one. This one is actually not saturated much. There was another signal. Okay. There was another very clipped signal previously that was much more saturated. So in scenarios like this, if you have a very long clip signal like this, in the find peaks function, you will find there was another value, threshold. threshold, you see another parameter. So in this, if you have a very saturated signal like this way, you can do two things. Okay, either consider them as one peak or do not consider them as at all. Okay, if the scenario is that if you don't want to consider those things at all, okay, see, you see this is a peak, but when you have something like this clip portion, by default this is considered as one peak. But if you don't want to consider the clip portion, like when you have a clip signal, you will not consider it as a maximum. Why? Can you answer why? Why?
Sir, because the peak was clipped.
Yes, the clip was clipped because you see, by default value or MATLAB, the find piece function is finding this way, but this peak is actually supposed to be like this, right? So that is actually the original peak. This is not the peak. Okay, so this is not actually the peak. This is supposed to be the original peak, but in your signal, that signal is chopped or cropped like this way. So sometimes if you have this kind of things like this way, you want to ignore this one, completely ignore. Okay, so when you want to completely ignore, you can use this threshold function to define it. If you have this kind of clip portion like this threshold is C. If you have this kind of range, different values in this range, okay, then it will consider this region, this entire region as a clip portion and try to will omit this one from your consideration. Okay, let's see. Let me show you. So let's come here. Section break, this one. Now, so if I put this threshold value, again, what should be the value of the threshold? Okay. See. If I put the value 5, this one. So let's put a numeric slider here. 1 to 100. So do it. 1. Okay. So see, if I put here, let's put it in 1 first. 3, 1. So you see, this is your original scenario for 1. If I increase this one to 7, to 5, to 3. So from 1, this is considered a peak. Now you see, if you give it 1, this is considered a peak. If you increase it to 5, some of them are gone, right? The threshold values, 10. You see, these bottoms are gone. Why? Why gone? The threshold should define the change should be in that range. If you go here, there should be some definition given here. Threshold. You see this one. If you go in documentation, at the end of the documentation page, you will find all the definition of each of the variables there, parameter values. Okay, I have showed you 2, 3, 3, including this one. I am showing you 3. Check the other ones as well by yourself. So you see minimum height difference between a peak and its neighbors is expressed as a non-negative ideal scalar. Use this argument to find peaks. These are only those peaks that exceed their immediate neighboring at least by this threshold. Okay. So if you do it like this way, you can change just like your previously using this threshold value. This will be too much. 25. So this one is now like more than 25. That's why it is still there. So check different threshold and see how your output is changing for this signal, for your the previous signal on your Sunspot data. Try to see the output for this one as well. Okay. Acha, the last one, load noisy ECG.mat. This will be your assignment. So section break plot. So this is, you see, what is this one? This is a ECG signal, just like a show. You can see this is a peak, then grows like this way, goes like this. So this signal is repeated, right? So this is a peak, this is a peak, this is a peak, and this is very noisy. The signal is quite noisy one. So you have to find your peaks, find your peaks from this one. Okay, so you have to try this at your home and see if you can find the keywords as well. Any questions so far? Any questions regarding this one? Find peaks.
No, sir.
Okay, so try with different threshold, different values, minimum peak provenance, then minimum peak distance. Try with different values and see their outcome, and to do the same for this signal. So you can do it for any signal and see how different things you can actually find out. And if needed, check the documentation. At the end of the documentation, the description of all the parameters or input parameters are given always. Okay, so try to do that one as well. So this is your first part of your lab. Now number 2. Now signal generation, this is a bit simpler one. I'm going to do it a little bit fast because we have to go to the third one as well. Now, this is very simple one, figure 4.4, signal generation and visualization. So how to generate different types of signal. Okay, if you are still not familiar with this one, and that's why I've just added this in this portion. So if I want to create a sinusoid wave or a square wave, things like that, how to actually do those things, that is within this within this lab, signal generation. Achha, let's see the outcome. The codes are already given here. You can directly see. So, see, for instance, if I want to, can you see this? See the screen?
Yes,
Yes,
sir.
sir.
Achha. So, first of all, if I want to put a sine wave, see, I am first defining this range. What is the range? Minus pi থেকে pi, minus pi to pi, minus pi to 2 pi actually. So pi value is 3.4. So 3.14. So that is why it is minus 3 to 6. And I'm calculating the y value, sine of x. This is in the radian. So now if you plot it, you get this curve, right? What is wrong with this curve?
The curve is not smooth.
Curve is not.
We've taken less samples. We require more samples.
Yeah, we need more samples. How many samples do I have here? How many? 10. Minus 10 থেকে 3 আর 3 6. You see, by default, this range is 1, right? The point value is 1. So if you do it, let's see how many values you get.
Sir, 8 value.
8 value, right? So it should be something like this. So now the default range is considered as 1. So you have to increase the number of samples in between. And that is what we call the sampling frequency. Okay. So if you increase it to like this 0.001, so that means from minus pi to pi or 2 pi. So the points are divided into range of 0.001. So you are getting many values. So what is the sampling frequency here? Sampling frequency is 1000, right? 0.001 means 1 divided by 1000. So 1 divided by 1000, that's your sampling frequency. So 1000 is your sampling frequency. If you use 0.0001, that would be 10,000, like this way. Now you can see the figure is very smooth. You have a smooth sinusoid curve from minus pi to 2 pi ratio. Okay. So like this way, sin pi, you can change. See the axis command, you can using the axis command, you can also change the range from which you want to show. Okay. Then you can also check the absolute value. You can perform any operation on this one, like the absolute value of the sin x. So it is giving you the absolute value. So the negative portion is chopped down. So negative portion is actually considered as positive, not chopped down, is now positive. And you have multiplied it as 0.5. That's why your amplitude has lower, like this way. You can perform many different operations, any operation you like using these values like this way. And you can, the same way, you can also plot multiple figures in the same plot. So now you can see first you have the sine wave, then you have 0.5 times of the sine wave, then you have minus 0.3 into sine wave, then you have the y to the power 4. So this one you can see different side. Okay, so you can do like this way. If you have a sine wave or cosine wave, you can generate any types of sine wave like this. Similarly, if I want to generate a square wave, you have the function called a square. You have the same distance and you have the square function. And this square function has a second parameter, that is the duty cycle. So what is the duty cycle of a square wave? What is duty cycle of a square wave? Eugene,
For how long it will remain in the peak?
in the positive side, not peak, positive, right? How long a square wave will remain positive, that is the duty cycle. So when I say define it as 75, that means 75%. So you can see in this signal, 75% of the time it is positive, and less 25% of the time it is negative, like this way. So you can create a square wave with different signal, with different duty cycle this way. Also, you can put your signal, multiple signals also. So if I ask you a question like this, generate a 50 hertz a square wave, sample at 1 kilohertz for 80 milliseconds. So the sampling frequency is 1 kilohertz. So that's why you have this one, 0.001. How long you want to show? 80 milliseconds. That's why this is 0.008, 80 milliseconds. And the signal should be 50 hertz. So you remember twice by ft, that's your signal. So twice by ft, that's the frequency is 50. So now you see this is your signal, a square wave like this way. Does it look like a full square wave? Does it look like a
No,
full
sir.
square wave? So why we have this one, why we have this? Why not a full square wave like previously? This one very clearly. Why not this one? Why not that one? মনে নাই যে ওঠার সময় একটা সিগন্যাল উঠতে কত সময় লাগে, নামতে কত সময় লাগে, there is a time it takes, right? Rise time, fall time.
Right.
You should, I think you should know these things by now. 3-2, right? You have studied those things. So the rise time and fall time, that's why you have something like this way. Okay, so let's not go there for now. Then you can also generate a sawtooth wave. You have the sawtooth function. Using this one, you can generate a sawtooth wave like this. So I have already provided you these files, so you can check with different things. You can also create a triangular wave by using the second parameter. To make it 0.5, the sawtooth becomes a triangular. Acha. Now you can also add some noise to the signal. You see AWGN function. First you create a square wave. That's your square wave. You can see the AWGN function creates a What is AWGN? AWGN refers to additive white Gaussian noise. Okay, so this 10, control bar here. Okay, now see, so what does this mean? The signal becomes less noisy or more noisy with value 2.
More noise.
Now 7, it is less or higher. কমতেছে না বাড়তেছে?
It's reducing.
Reducing. Okay, so AWGN stands for additive white Gaussian noise. Okay, it stands for additive white Gaussian noise. Okay, so and the second parameter is the signal to noise ratio. So higher the value, that means compared to the noise, signal is that much strength. So 23 means the signal is 23 times stronger than the noise. That's why you can see that the signal is less noisy. If you increase in further, you can see it is almost the signal you are getting. So but lower, you can see this is very noisy signal. So the value represents how much strong your signal is, the signal component is compared to the noisy component. So this way you can actually add some noise to your signal. That actually happens to simulate a real world scenario, because that actually happens in your when you actually look at a signal. When you save a signal from a real source, there should be some noise there. And this is one type of noise, white Gaussian noise. There are other types of noise as well. Salt and pepper noise. This is enough for now. So you can add a noise like this. Okay, noise signal like this way. So see, in a sinusoid wave, if I add a noise like this with a SNR of 10, you can see this sinusoid wave is deviated from its original shape. Okay, like this way. You can also create a Gaussian pulse here. You can also create, okay, there is a normal PDF. Using this, you can also create a Gaussian pulse. There are two parameters in the Gaussian pulse, the mean value and the standard deviation. Changing the mean value and standard deviation, your Gaussian pulse will shift left or right, and the range will change like this way. So you can see with different, this is the mean 0. So the mean has changed, the standard deviation has changed, that's why it is flattened like this way. You can also create a pulse train like this, okay, like a continuous set of pulses, okay, Gaussian pulses. You can change this one, okay. So using like this way, using this course, you can create different types of signals on your own. We'll mostly work with the sinusoidal or square waves. You can also create other signals like this. Any question? Any question? I I do complete it a little bit faster because we have one other things to complete, cover. Now, last one, filter operation. I believe you are already familiar with different types of filter, like low pass filter, high pass filter, band pass filter. এগুলো পড়ছো না?
Yes, sir.
Yes, sir.
Now you see, this one I first tried to do it, thought of doing it in the image domain. I think didn't do it because I'm not sure how much you have the knowledge. Acha. So your like for instance, if you consider your low pass filter or high pass filters, these are linear filters, right? Linear filters in which domain? In the frequency domain, right? You're chopping down the high frequency components. It works like this way. So in the frequency domain, you are considering these things. You are already familiar with these types of filter operation. But when you are working with values like signals or images, okay, you can also consider these filter operations in the space domain. In the you can also consider these operations in the space domain. What does it mean by space domain? See, if you have an image, so the edges, let's say for instance like this, let's draw an image. This is the eye. Okay, this is the person's face. Achha. If you consider the pixel values here in these regions, is there any change in the pixel values? Almost same, right? If I take an image
Yes, sir.
in the forehead, there will be almost same. But whenever I go to this one, this eyelid, there will be a certain change in the pixel values, right? Because that will be completely black. So there is a major change in this one. So this is the edge, right? বোঝা যাচ্ছে আমার কথা? Again, if you consider from
Yes,
this side,
sir.
this side, this side, whenever you come here, there should be a very change here. So in terms of image, so the low frequency component by means, we means these ones, and the high frequency component, we mean these edges. Okay, these edges are the high frequency component because there is a sudden change there. So that's the idea of space domain consideration. In the space domain, you have the in an image, you can have low frequency component and high frequency components. So you can also have this kind of low pass filter, high pass filter in the space domain as well from the perspective. How so? So if you look at the pixel values, whatever the pixel values you have, let's say I have the values of 2, 0, 1, 7, 9, 33, 4, 32, 1, 2, 0, 2, 1, 64. So you see, these values are very high, these values are very high, right? Now, do you know convolution operation? Convolution পড়ানো
Yes,
হয়েছে?
sir.
So if I have, this is called a kernel or a window. I can put this kernel here on top of this one and multiply point-wise multiplication. If I perform it, so whatever the kernel value is, let's say this is the kernel value. Will it change the value any value here? I multiply it and replace the middle value, this middle one, with whatever the summation that you get. Will there be any change here? Let's look at another kernel. -1, -1, -1, -1, -1, -1, -1, -1, 8. If you put this one in the kernel, will there be any change? See what we are doing. Multiply this value with the respective value. This becomes -2, then -0, -1, -3, plus 4 32, then -32, -1, -0, -0, -2. So what is the outcome? -2, -3, -2, 3, 4, 5, 6 divided by 1/9. Just take the average. So you see, very sudden, the value becomes even smaller. Does it become smaller or larger? Smaller, right? আমার কথা বোঝা যাচ্ছে?
Yes, sir.
Now the same filter, if you just put it here, the middle value becomes this 32. তখন কি হবে? 0, then are you following what I'm doing? -1, -7, -4, 8 multiplied by 32. That's a huge value. Then again -1, -0, -2, -1. So now what do you have? 7, 4, 11, 12, 13, এখানে 8 2 16, 24. So something like this, divided by 1/9. So it is like almost almost 30 এর কাছাকাছি. So you see, when you are passing this one, the smaller values only becomes smaller, larger values only becomes larger. If you just don't put the average, it will even the effect will be even more. So it makes the larger value larger, smaller value even smaller. So this is like a high pass filter operation. You see the edges, these edges are this. this 32 is like an edge because this is a significant change compared to the neighborhood pixels. So if you multiply it like this way, this filter with this one, if you putting it like this way, multiply this way, the middle value will become even more larger. Surrounding values will become only smaller. So it will highlight this edge. Okay. This one is all pass filter. It will not change anything. So this is like the operation of filter operation in the space domain. So filter doesn't mean only in the frequency domain. It can also have the space domain consideration. Now, I have not included this one, so forget about it. Don't worry. This is the filter operation in case of image. Now, in this lab, what you are doing, we will try to do. You are familiar with low pass, high pass, these filters. I try to introduce two non-linear filters. Non-linear filters. So these filters are good at removing the high frequency or low frequency component, low pass filter, high pass filter. But if you have a noisy signal, if the signal is noisy, then this low pass filter, high pass filter is not very good. Are you following? If your signal is noisy, low pass filter, high pass filter, they are not very good. So in case of noisy signals, you need non-linear filters. What kind of non-linear filters? One of them is median filter. Okay. So a median operation is actually a non-linear operation. How do you calculate a median of a value? So if I have this list of values, range of values, what will be the average value? Average value is summation of all the values divided by the number of values, right? But for median, we'll sort the matrix like this way first: 2, 5, 6, 8, 9, 10, 32. Then whatever in the middle, that will be your median. So the median value usually goes to the somewhere in the middle. So in median filter, if we look at the median filters, so it will perform the operation in the space domain that we are going to see. So let's look at the output. It will be much easier for you to understand. So I have already discussed here what is the window and what is the median filter, how we calculate. Now see how the operation of the median filter. Let's see. Filter operation. So this is your original signal. Okay. This is your original signal. Let's run this one. So on top of this signal, so this is your original signal, and the fluctuating one, that's your sinusoid. So let's just put that one. So I have another signal here. So this is your signal now, a little bit of distorted because one sinusoid is added with another sinusoid. Okay. So your signal is quite distorted. Okay. Are you following? দেখা যাচ্ছে?
Yes, sir.
নাকি সবাই হারাই গেছে সবাই? So you see the signal is quite distorted here. Now, what is the frequency component of these signals? What are the frequency components of this signal? You can see here twice the FT. The first one is the 3. That is the primary signal sinusoid. 40 is the noisy sinusoid added like this way. আচ্ছা যাই হোক. Now, if I put a median filter, this is their function, median filter 1, it performs a filter operation, median filter on this signal, this X2. So there's a mistake here. And this one is the window size, something I have already described in your lab manual. It is like the like 3 by previously we saw in the space domain 3 by 3 shape, right? It is like how many neighbors we are considering to consider this filter. Okay, so if you check this one, let's put this one X2 and then 0,1. Yeah. Okay. Now you can see this was your original signal, and your original signal is recovered from the filtered one. So this was your original signal, right? When I pass a median filter like this way with a filter size of 10, change so is there any change? Do you see any change here? কোথায় হারিয়ে গেল সবাই? See, originally there is no change. If you increase the filter, this was the original signal. If you increase the filter window size, now you can see as I increase the filter window size, you are getting more and more this portion. You are getting more and more a more sinusoidal wave. Okay, so this is like increasing the shape of your kernel size. Now you are get a more better sinusoid wave. So filter operation works like this way. Now let's look at for this one. You have already seen this one. This was your Gaussian kernel, Gaussian noise added to your square wave. So if I put a median filter, this will be like this. If I add a kernel of 10, this will be much better. So you can check with different values. 15, it looks like this. So with different values, you can see with different values, you get different output. Okay. Or what is the order? If the order is high, it becomes very lower. আমার কথা কি বোঝা যাচ্ছে নাকি কিছু বোঝা যাচ্ছে না?
বুঝতে পারছি।
বোঝা যাচ্ছে?
So
So
can
this
you repeat what is order?
order is the size of the kernel. Okay. How many values you are taking on left and right before you actually creating this? আচ্ছা আমি এখানে দেখাচ্ছি। So how many values are here? 1, 2, 3, 4, 5, 6, 7, right? So the order is 7. Okay, this is one dimensional filter, so order is 7. How many values you are considering? Neighborhood pixels or neighborhood values to consider the filter. If you're considering 10 values, that means on the surrounding of the each center value, you are surrounding 5 left, 5 right. Okay, so that's why that is called the order. So the larger window you take, that means you are considering larger larger shape. In case of filter, in case of image, you have to consider 2D filters. Then the order becomes 3 by 3. This is a 3 by 3 filter. If you make it 4 by 4 matrix, that will become a 4 by 4 filter like this way. In one dimensional, this is your filter shape. So you can see if we have considered 10, J10. Okay. If you consider a window shape of 10, it looks like this. For 15, it looks like this. Okay. So try with different types of values, okay, different orders, and see what is the result. Okay. If it is too high, your signal will be too cropped. Okay. It will deviate from your original square wave. If it is too small, it will not be able to change the original, reduce the original noise. For instance, this one, you can see the original noise is reduced, but to some extent, not very nicely. So output signal is not very well. It's not very good here. So this is your noisy signal. Let's only put the now we can see. So when filter it, this is the original signal. When you filter it, it's not very good. Okay, try to see other options and see what is happening there. You can see from there what is happening there. The last one, the last one is Hampel filter. So this is another type of filter. You see, you have the original sinusoid wave. Then I put some outlier here. Okay, so median filter we use for when you have a noisy signal, especially Gaussian noise. To remove those Gaussian noise, we use a median filter. So sometimes your signal have something like this, an outlier. This is not noise, but an outlier. In scenarios like this, we can use this kind of filter that is called a Hampel filter. Okay, you have the function Hampel filter. You see, when you put Hampel filter, the filter option is this red line. You see these filters are becoming like this. So, because more clearly, you see this was the outlier and this is chopped like this way. So Hampel filter will reduce and make the signal much more original, close to the original shape, like this way. Is it clear? So this is the operation of Hampel filter. So these are two types of filter. There are many filters. This is two I just introduced you. So if you have a signal that is very noisy, you should try to go for median filter, and that will find the order of the filter that is actually make your noisy signal much more better than close to the normal signal. And if you have some spikes like this way in your signal, that happens in your previous ECG signal. In this ECG signal, there are some spikes there. So you should actually try to pass a median filter here to see if you can make this signal much more stable. I'll try to put some assignment from these types of assignment in your for this lab. Okay. Any question? Any question? Okay, let's finish
No,
it.
sir.
Okay, let's finish this lab today. You can write your student ID in the comment section. If you have any questions, let me know.